Welcome everyone. Today I'll be talking about synthetic fibers, what they are, how they are made, their properties, applications, and the impact they have on our environment. Introduction and history of rayon. Rayon fiber, also known as viscose rayon, is a semi-synthetic fiber made from purified cellulose. Typically derived from wood pulp, it is a versatile and affordable fiber that combines the benefits of natural and synthetic fibers. Rayon is also known as regenerated cellulose fiber derived from wood pulp, originally called artificial silk, rebranded as rayon in the early 20th century. The main objective in manufacture rayon was to provide a cheap substitute for silk. Rayon were originally known as artificial silk because they resemble the natural silk and are soft, cool, light in weight, attractive in appearance. The imitation is done very cleverly and layman is not able to distinguish silk from rayon. Rayon fabrics and rayon yarn. In 1946, India's first rayon factory was started in Kerala. For the first time in the world, bamboo and eucalyptus has been successfully used for manufacture of rayon grade wood pulp. It is first developed in the late 19th century as an alternative to natural silk. The commercial production began in 1891 in France by Count Heller. Improved viscose process patented by Charles Cross, Edward Bevan, and Clayton Bedell in 1892. The name rayon was officially adopted in 1924 by the US textile industry. Modern advancements have led to eco-friendly versions like Lyocell. Microscopic structure of rayon. When you see under the microscope, the fiber appears smooth and rounded. It has characteristic marking which vary according to process. Viscose rayon fibers are rod-like with numerous longitudinal threads like serrations or lines that are spiral and somewhat glossy. These are due to identification of fiber surface. Cupra ammonium rayon. They are rod-like with no serrations or markings. They are fine and glossy and resemble silk more closely than other fibers. The cross section appears is small, smooth and nearly round, occasionally slightly oval. Steps involved in manufacture of viscose rayon in are cellulose extraction, steeping, pressing and shredding, aging and xanthation, dissolving and ripening, filtration and spinning, drawing and finishing. This picture explains the process of viscose rayon in industrial level. Let us see the manufacturing process of viscose rayon. The overview. In this process, spruce chips are used. Spruce logs are reduced to wood pulp and purified for cellulose base. Wood pulp is treated with caustic soda to form alkali cellulose. It is treated with carbon bisulfide to form cellulose xanthate. This is dissolved in dilute caustic soda solution. A reddish or orange liquid is formed. The liquid is then filtered and then kept for aging until a thick fluid is formed, which is known as viscose. This fluid is forced through a fine jet into a dilute solution of sulfuric acid, that is, in coagulation bath. In this way, cellulose is regenerated into continuous fibers. The largest portion of rayon is today manufactured by this process. The cost of production is comparatively low and excellent fibers are produced. Steps involved in the manufacturing process of viscose rayon. Let us see in detail. Rayon is a semi-synthetic fiber because it is derived from the natural cellulose but undergoes chemical processing. The viscose process is the most common method used to manufacture rayon. The process involves several steps from extracting cellulose to forming fibers. First step is cellulose extraction. Rayon is made from natural cellulose which is obtained from sources such as wood pulp, bamboo and cotton linters. The quality of the final fiber depends on the purity of the cellulose source. Wood pulp is commonly used because it is high cellulose content and is easily processable. Steeping. The extract cellulose is soaked in sodium hydroxide, also called caustic soda. This treatment swells the fiber, make them more reactive for further chemical processing. The resulting materials is called alkali cellulose, which is essential for forming rayon fibers. Pressing and shredding is the next process. The excess caustic soda is removed by pressing cellulose pulp. After pressing, the alkali cellulose is shredded into small pieces to increase the surface area for better chemical reaction. This shredding form is called white crumb because of its appearance. Aging and xanthation. The shredding cellulose is aged for a specific period to break down its molecular structure. It is then treated with carbon disulfide, converting it into a yellowish compound known as yellow crumb. This process called xanthation is crucial for transforming cellulose into a suitable form. Dissolving and ripening. The yellow crumb is dissolved in a dilute sodium hydroxide solution to form a thick, honey-like liquid called viscose. The viscose solution is allowed to ripen for several hours to improve its spinning quality. Filtration and spinning. The viscose solution is filtered to remove impurities that may affect fiber quality. The filtered viscose is then forced through fine nozzles, that is spinneret, into a sulfuric acid bath which solidifies the viscose filament. These steps transform the liquid solution into rayon fiber. Drawing and finishing. The fibers are stretched to increase strength and alignment. The fibers are washed and dried to remove any remaining chemicals. The fibers are stretched to increase the strength and alignment. The rayon manufacturing process involves chemically converting natural cellulose into fibers using sodium hydroxide and carbon disulfide. The key steps include cellulose extraction, steeping, shredding, aging, dissolving, spinning, and finishing. This process produces a fiber that mimics the feel of a natural fiber like silk, cotton, and wool while being cost effective. However, environmental concerns regarding the use of chemicals have led to the development of eco-friendly alternatives like lyocell. Properties of rayon. It involves both physical and chemical that determines its functionality and performance. Physical properties: rayon or soft, smooth texture offering comfort similar to natural fiber. It has high absorbency, making it suitable for moisture wicking application. Rayon has good drapable, making it a preferred choice for dressing, scarves, and home textiles. It can imitate silk, cotton, wool, or linen, making it highly adaptable. However, it is weak when wet and prone to wrinkle, required carefully handling methods. Chemical properties of rayon. Rayon is sensitive to strong acids which can degrade its structure. It has good resistance to mild alkalis, making it safe for certain chemical treatments. It has high affinity for dyes. It will absorb dyes quickly and can produce vibrant colors. Resistant to organic solvent, making it compatibility with certain fabric treatments. These properties highlight both the advantages and limitations of rayon. Applications of rayon. Due to its versatile, rayon is used in a variety of applications like apparels in dresses, blouses, skirts, suits, and sportswear because of its comfort and elegant drape. It is also used in home textiles like bed sheets, curtains, upholstery, and towels. Benefit for rayon, soft and absorbent nature. It is used in industrial application like medical textiles, tire cord, and non-woven products due to its strength and moisture handling capability. Its drapability makes it one of the most widely used semi-synthetic fibers in the textile industry. Care and maintenance of rayon. Proper care is essential for maintaining rayon fabrics. Hand washing or dry cleaning is recommended. Machine washing can weaken the fibers. Rayon should not be air dried rather than the tumble dried to prevent shrinkage. Use medium heat and iron while the fabric is slightly damp to avoid scorching. Following these care instructions ensures that rayon garments retain their quality and longevity. To conclude, rayon serves as a bridge between natural and synthetic fibers, combining the comfort of natural fibers with the affordability and versatility of synthetic alternatives. It is widely used in fashion, home decor, and industrial applications. However, it requires careful maintenance due to its delicate nature, especially when wet. Despite its limitation, rayon remains a popular choice due to its softness, breathability, and ability to mimic luxurious fabrics like silk. Thank you.